Hello everyone, welcome to PD Smart Education. Today our topic is aromatic hydrocarbons. In this topic we deal with what are hydrocarbons, what is aromaticity, and the simplest hydrocarbon benzene with its physical and chemical properties. Now let's start with hydrocarbons. So what are hydrocarbons? Those compounds composed of carbon and hydrogen as major constituent are known as hydrocarbons. CH4, this is the simplest hydrocarbon consisting of carbon and hydrogen only. This is methane, the simplest hydrocarbon. They may contain oxygen, sulfur, halogens, nitrogen, etc. as the minor constituent. Two examples are here, HCOOH and CH3NO2, methanoic acid and methane nitrate. In first case, in methanoic acid HCOOH, we have two oxygen atoms, while in case of CH3NO2, we have oxygen and nitrogen. These all are the minor constituent. The minor constituent may be any from the periodic table. Now we have aromaticity. So what are the properties that makes the compound aromatic in nature? Those compounds which are flat, planar in its structure with alternating double and single bond are the aromatic compounds. This is not only the single case for which a compound becomes aromatic, there are other requirements too. Each carbon has sp2 hybridization and it must obey the Huckel's rule. Huckel's rule is 4n plus 2 pi rule where n equals 0, 1, 2, 3, 4, so on. What is the basic assumption of Huckel's rule? It states that the cyclic planar compound having alternate double and single bond with sp2 hybridization, each carbon atom consisting of 2 pi, 6 pi, 10 pi, 14 pi or 18 pi electrons are aromatic in nature. This is the assumption of Huckel's rule that helps us to determine whether the compounds are aromatic or not aromatic. Here we have the simple table in which we can show whether the compounds are aromatic or not. Not only the compounds consisting of carbon and hydrogen only, compounds like phenol, nitrobenzene, aniline, benzoic acid, benzaldehyde, etc., which are derivatives of benzene, are also aromatic in nature. Let's know about the simplest hydrocarbon, benzene. So, what are the chemical physical properties of benzene? Let's start with the physical properties. How can you determine whether the given substance is benzene or not? Benzene has the molecular formula C6H6. It is the simplest hydrocarbon which was discovered by Faraday in 1825 and synthesized by Berthelot in 1870. It was discovered in early 1800s and synthesis was made possible in late 1800s. Due to the huge gap, scientists proposed a lot of structures. We have various structures of benzene proposed by various scientists. We can see them. After knowing about some of the structures of benzene, we have to know about the physical properties of benzene. So what are these physical properties? So that we can detect whether the compound is benzene or not. It is colorless liquid, insoluble in water and soluble in organic solvent. It is insoluble in water because water is the polar solvent and it is able to dissolve the compound if it can form the hydrogen bond, or otherwise the compound is not soluble. And in case of water, in benzene, it cannot form the hydrogen bond and it is polar solvent, that's why it could not dissolve benzene. While benzene is soluble in organic solvent, those compounds which are organic in nature. Now, what is its order? We can know the order of benzene is aromatic order. It bonds with the sooty flame. The flame is very black in color. The bond in benzene is 1.39 Armstrong, which is greater than the carbon-carbon double bond 1.34 Armstrong and smaller than the carbon-carbon single bond 1.54 Armstrong. That's why benzene can be represented by the resonance hybrid structure where all the carbon-carbon bond are equal in nature. All the carbon atoms in benzene are sp2 hybridized with bond angle 120 degree, thus represented by resonance hybrid structure. The resonance stabilization energy of benzene is 36 kilocalorie per mole, that is very low. It gives one monosubstituted product and 3 isomeric disubstituted product. When substitution occurs at single place, the substitution at any of the 6 carbons is equal. That's why one monosubstituted product. But on the substituted benzene, if further substitution occurs, there are 3 disubstituted products, ortho, para or meta substituted product.